let's try to draw a graph of position versus time. Now, let's use it as our time axis. Let's use the units of seconds. We know one clap was 3 seconds. And we use so this is then position. So let's just get a scale going. Let's say that is equals to 1 square on the carpet. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. So that will then be 10 squares. So we're just going to use as a measure of length the squares, the length of a square on the carpet. So where was Sheehan at the beginning? So what do we need to specify its position? We need an agreed upon point of reference. So let's say Sheehan's initial position is our 0 position, our agreed upon point of reference. So let's say right at the beginning, he was at position 0, and we say at time, whatever the time was, so it was about 20 past 8, we say 20 past 8 now is 0. That's our 0 time. So 3 seconds later, we know Sheehan advanced by 1 square. So after 3 seconds, he was 1 square away from his initial position. And we're going to take his forward motion as indicating motion in the positive direction. So I'm only going to plot positive values on the x-axis. After 6 seconds, he had advanced 2 more squares, so 1, 2. So his position would be over there. After 9 seconds, he would have advanced 1, 2, so 1, 2, 3 squares further yet. After 12 seconds, he would have advanced 1, 2, 3, 4 squares. So this is approximately then Sheehan's change or his position as a function of time. And we can now use this to get some information. The first bit of information that we can ask ourselves is, well, what was Sheehan's change in position for the whole interval? So, sorry, how do I spell your name? S-H? E-N? E-A? S-H? E-A. Aha. H-A-N. Sheehan. There we go. Okay, what was Sheehan's change in position after or during our 12-second interval? So his initial position, so where did he start out from? So let's say the x-axis pointed to my right, so to your left, as it should. So initially he was just at the reference point, so we say his x position is equals to 0 squares. So 1 square, there we go, of carpet is approximately, I'd say, about 0.3 meters, just if you want to convert that to meters. After 12 seconds, so Xian's position was at, if we look at our graph, so after 12 seconds, the position is 10 squares away from, or let me just make sure, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So after 12 seconds, his final position, let's call this initial and final, is 10 squares away from the reference. Now, what do I mean by change of reference? Or sorry, by change in position? So what I mean by that is, if I was standing next to Xian when he began, and you asked me, where's Xian right now? I would say, at the left. Then I close my eyes, 12 seconds later, you ask me, where is Xian now? And I would say, he's 10 squares in front of me. So, according to me, if I were staying still at the point of reference, what would Xian's change in position be? Well, he is now, the difference is 10 squares in front of me. So, what we mean by change in position is what is the difference between the end position and the start position as seen from the point of reference. Right, and just you can note, this will always be something like so this will always be something like the shortest distance between the points plus a direction. So if we think back to our x-axis, we can now define the position, or the change in position, which we're going to use this symbol for that. It's called just delta x. It's just a label or a name. And we define this as the final position minus the initial position. Right? So if, for example, delta x is smaller than 0, so if delta x over here is a negative number, it means that this must be larger than that. Right? Or alternatively, we had motion to the right or along negative x. Right, and then the reverse is true. If delta x is greater than 0, we had motion along positive x, or to the left. Now there's a fancy name for this, and this is just called the displacement. So delta x, we call that our displacement. And it is equals to the final position minus the initial position. Right, remember displacement, it has a direction. Because if I want to answer the question, what was Xian's change in position with respect to me, if I just say 12 squares, it can be 12 squares in that direction, 12 squares in that direction, 12 squares out the door. I have to specify the direction to be absolutely accurate. Right, so that is position. And the difference in position we call displacement. And this allows us now to gather